Hi everyone. Um my name is Illia. And today we are going to talk about TypeScript. And let me a bit introduce myself. So I'm a software engineer at Cisco Systems. Also, I'm a member at Limon.io community. It's a really good freelance community where you can join to us and uh, to do some good stuff projects. And also I co-member at Effector.js as a state management library where we faced a lot of TypeScript issues and tried to solve that. So if you're gonna use that, I'll be happy. And let's go to the problem, our problem inside the TypeScript, or not a TypeScript, about the project. So let's imagine that you started a new project and you create your new function. And it looks like that you have simple function with simple types. But after some time, you would like to make some more complex, some universal, and for that you create some kind of generics. I'll explain a bit later about that, but your function should make something difficult than did before. A bit later, you realize that you would like more. You would like to use hard stuff from the TypeScript, and you do some other stuff. And then you need help from your colleague, or you need help from yourself, because you forgot actually what did you do here. And then you need to pray, or, I don't know, do something else. And here, I would like to say that it's not too hard to read the TypeScript stuff if you really understand the definition of some kind of things inside this language. And before we are going to our examples, let me tell you what exactly going to be described here. And first of all, we would like, I'm going to translate some TypeScript definition to pure JavaScript stuff. And for example, how to iterate in TypeScript based on type level, by key, by values, how to add modifiers, aliases, how to inference your type, and in final cake is make our complex type. And before we do that, let's scan the QR code and make some vote for clear understanding about our knowledge and where we need to pay attention. Okay, and while you are scanning, so are you happy with the TypeScript? Do you use this language in your job? Yeah? And are you enjoy? Sometimes, yeah? Because you faced extent or some generics and yeah? Would be great how in C++, where you don't do nothing. So, do you see the vote? Okay. Cool. So, take some moment for understanding what is going on. So Slido is also our project. You're welcome to use. It's free. Okay. So infer is a magic word. Yeah. Cool. And generics also, because generics should have conditions, and when we need to make a conditional generic, it's something bad. Yeah. Okay. Okay. All done? Let's go. Let's go to the code. So I prepared some example for you. But before we start to show an example, I use some advice from my colleague to show, first of all, the last example. That's what we want to do in the final. So some kind of function with some kind of properties, but everywhere you can see magic word any, everywhere is any. We like any, right? The best solution. So we try to solve that in our final example. Before we start to do that, let's talk about generics. So what is a generic? If to translate to our human word, generic is the kind of spot where you can save some kind of information on the type level. Then TypeScript try to understand what are you doing, and then return this value for you. Oh, yeah. One more. Yeah, okay. Okay? Okay. Okay. What is going on? So here we prepared the spot where we would like to save the information on the type level, and here I pass the array of numbers, and then in the result I would like to understand what I'll get in the final result. So what included to this array? If we hover to our result variable, we can see the number. So array of number, in the result I'm getting the number. Return value is some kind of t. So we pass array of t, TypeScript understand array of what exactly that, saves this information to the generic, and then we return this generic. Another example is an array of string. In the result we have string. Okay, it's simple. Already simple for us. Another example, extends. So here we need to understand how to translate that to the JavaScript language. Extends have two options. First option is to make a limitation on the type level. What does it mean? In this example, we tell to TypeScript that the generic S could be, can be view or nest. View is a framework, nest is also a framework as a string. And then we return this S. Why we do that? Because right now I can, on the type level, say to TypeScript which values allows to pass, or nest or view. If I do something else, it doesn't work because some string does not satisfy the constraint view or nest. Yeah. So if I pass the correct string, TypeScript is happy. Okay, and why do we do that? Because then we have another example, how to understand extends at the condition. Here, I used the example from the previous TypeScript file, where skill could be or view or nest, and then in the new my type required skill, I prepared two spots. First spots could be or frontend or backend, and then this is the limitation. And then I create a condition. If P, my first generic, is frontend, let's create the new type based on our union, view. If it's not frontend, it's nest. Okay, and let's check it works or not. So I created type user where skill is the frontend. So my main domain is the frontend. In the real JavaScript variable, I can pass only view because I limited that on the type level. If I change that to the backend, I can pass only nest. Okay? So that's how works limitations and conditions on the type level. So you don't need to match that on the JavaScript level. You can just do that on the type level, and it's automatically the tests for you. Then, why do we need the examples? Because we have some kind of built-in types in the TypeScript, record, peak, omit, and so on. And I would like to describe something from that. And let's replicate the record type. So how to create a typed list in the TypeScript. For that, I tried to create the type where keys, typed keys, should be or string or number or symbol. It's valid for the JavaScript objects, and value can be whatever. And then we can iterate with in special operator by the key union type, create the variable p, and then put our second generic. So under the hood, TypeScript convert your union type, like in my example, dog or cat, to the array of typed strings. Then TypeScript allows to use these values as a keys. So here in my example, JavaScript, just a JavaScript object, I can add cat or dog key where the value is some kind of object with a string. So we can use records everywhere where you know about the keys, and you need to create all keys from your I don't know, payload to the server, for example. So all keys are required. Oh, yeah, because need to it. Yeah, but for example, if you need to iterate by keys which you don't know, for example, you got you created some type separately, yeah, and actually your generic type doesn't know about the keys from your separate type. For that, we can iterate by keys of something. Here, I use the pick type from the TypeScript. This is the type where you can pick specific keys from some other type. And at the same time, you exclude some other unnecessary keys for you. In my case, I have the type framework where name, language, and stars is the required keys. Yeah, but in my new types, my pick framework, I pick only language and name. How does it work? So here we pass the type by default, our framework, and then we limitate the second generic by the keys from the first type. So key of T. So why do we need that? Because if we don't limitate by the keys from the first type, I can type what I want here. But right now I see the error because we limitated our generic by the keys from the first object. That's why we need to iterate by key of. Then limited by key of, sorry. Then I iterate by the keys on the type level and return p from t, like in JavaScript. So you would like to get the value by the key, right? And we do that on the type level also. So that's how works pick from the TypeScript built-in types. And that's how we can iterate by some keys from the other type. Okay? And kind of a similar example, but some additional thing is how to add modifiers. So for example, you are going to make all your keys from the base type optional. So here you can see the address only optional, but here when we create the new type, we say user should be wrapped to the type myPartial, and then all my keys from the user type are optional. Okay? How does it work? How does it work? You can add modifiers on the type level. We limitate our type, our generic, that it should be only object, and then on each key from this object plus optional, should be optional. The same works for the required keys when you need to remove optional parameter everywhere. And I just brought the example where you can use modifiers on the left side from the key. So on the right side, minus and operator, plus operator, and on the left side also it works. So limitate by the object, iterate by the keys, and add some optional parameters. The interested one. How to get some information, actually types, from another type under the hood on another type. In our case, I created the function which returns the object with the keys name string. Then I convert this JavaScript function to the type level. And here I would like to understand what exactly returns this function. My return type allow to have the some prepared spot t where I limitate, so I not limitate, I check if that is the function. Please, let's check to the return value of this function. And if we have the return value from this function, let's move this type on the high level, so to the first level of our type, and return this value. In our case, if we check, type u is name string. The same works if you would like to get the array of parameters from the function. So right now we would like to move to the first level, the type from the parameters. And here we doesn't matter what returns this function, we just return R. If it's not a function, we return never. Yeah. And I just showed the example where you can use info for getting the type of array. If you, for example, would like to understand what is going on inside the array, you just can get the type from the array info. I described that because we need that in our final example. The last one. So what is as? So I know that a lot of us use as for casting types in our production code, because sometimes we need to do that. But here, I would like to show how to use as on the type level when you create your own types. And how does it work? Let's show what is that omit. Omit is the type where you would like to use the type but exclude some other key. Here, omit has name, age, and address, and I would like to exclude name from my base type. And here, so I can pass address, I can pass age, but there is not available name because I exclude that. How does it work on the type level? First generic is the object, is our type. The second generic is the keys from our first object. Then I would like to, first of all, I would like to iterate by keys from my first object because I need to iterate all my keys. On type level, I would like to make an operation on each iteration of my union. I mean keys from the object T. On each iteration, it's kind of loop. I would like to make a condition. So let's iterate by key of T, create variable P, and then on each iteration, I would like to check if P extends K, so if P included to the array of, included to the union, in our case is the name. If included, let's return never. We don't need this key. Then, otherwise, we return this key, if we need this key, and then get the value P from T. So, we do an operation on each iteration, okay? So, that's how we can use as operator on a type level. So, that's all what I gonna show on the type level, and let's return to our example. Our example, it's kind of function which has few properties. Data is a function, computed is the object of some functions, and the methods. My goal is to get the keys from the context of object, which I create here in data function. So I need to use these keys everywhere. The second goal is also use the keys from the context of object, but here full name is a function, but I would like to return and get the return value. So I don't want to call this full name as a function. I would like use it like a getter. Okay. So access properties from this and get string, not a function. Here I just would like to get the properties from the data. For that, I created the function, the file component, where I can pass the options, and then I need to collect all my information, what I write inside the defined component, to some spot. And let's prepare this spot as a generics, data, computed, and methods. Yeah, and I'm going to save all these keys inside these generics. For that, let's save this generic to our type options. Also, pass data, computed, and methods. Error because we did not create the generics inside the options. Okay, let's do that. Data, computed, and methods. Okay. Here errors is gone, but here we need to use this. We need to use this generics. So, what is the data? Data is the function which returns something. Yeah. Let's do function which return the data. And let's hover on our function. Here we can see that first generic was filled by the keys from the data. How does it work? So we created the data, Typescript inference these values and try to convert that to the types, save to this generic, data generic, and we put this generic to our options data, options generic. Okay, then let's do that. Let's do the same for the computers and for the methods. So we would like to return computed and methods. I don't, it's not a function, it's an object. So that's why here is a function, here is an object, as you can see in our example. Then we have the error because property name does not exist on type full name. Yes, because we didn't say on the type level that we work on the same type, same context. We need to do that. For that, I would like to use the built-in TypeScript type, recursion type calls this. So I would like to say the TypeScript that this should be computed with this context where I would like to pass information about data, about computed also, and about methods. So it can be a bit confused because we use computed here and we use computer here, but how does it work? First of all, we save the information about computed, and then we pass this information to this type. Then the last one, we need to do the same for the methods, data, computed, and methods. And here we can see that we allow to use our properties because we say the TypeScript that we work in the same context. Here also it works, but full name is a function. It's not what we are expecting. Yeah. Let's convert our function to the scalar values. It's a string, number, or whatever, not a function. We would like to get what is going on here and return value from here. For that, I prepared the type unpack computed, and what should be here? We should put the information, so prepare the generic, where we are going to put information about computed, and then I'm going to iterate by keys of the computed, so create the property in key of t, where I need to check if that's really function, if it's function, so p from t extends function, yeah, if it doesn't matter what gonna be in the arguments, but we would like to get the return value from the function r, and if we have the return value, actually if it's a function we return the value, yeah, from that. Okay, and then let's use unpack computed here, and let's use unpack computed here. We've wrapped our computed to this generic type, and here we can see the full name is actually string, at what exactly we want. We can finish here, but built-in type record. So what do you mean? To the built-in type my record, yeah? Ah, yes, I can. Yes, of course. I also can use built-in type return value. Yeah, I can use. So I can make a shorter that, but I would like to show how to use the infer. Okay. Then the last one. I save the defined component to the variable component, but my last wishes is use these all properties outside of the component. Let's create another spot where we will collect our data. Okay. Let's create for the defined component a new generic spot where we are going to collect data, collect unpack computed, and methods, and return to R. Your question was, can we use the record? Yes, we can, but we need to pass string as a key. And here I can check component returns age, full name, name, print, and surname. Actually, that's all. Thanks for your attention. If you have any questions, you're welcome. If you have some online questions, there's my social media, so you're welcome.
We also have some gifts for questions, right? So you have some incentive. Okay, Andrei, I'm coming to you. We have question number 1.
Thanks, Illia, for presenting. The question is, everyone who read the Effector.js source code or React Router DOM source code saw those like monstrous, pretty huge generics, extends generics, and so on.
Yes.
How do you guys test those types? Not the methods, but types.
We parse, unfortunately, we parse the text from the response of TypeScript live server. So yeah, so we are getting the result from the TypeScript message and just parse if it's equal to our expectation, unfortunately.
Answers your question? Yes, confirmed. Question answered. 1 is done. Do we have more questions? Nice.
First of all, thank you for a very practical presentation. So in the last final example, you showed Vue style code. So what do you think about Vue.js TypeScript support? Is it better than React.js or worse? Or
Vue?
Yes.
You are talking about second or third version?
It can be the latest one, third, but two is also.
Third one is better, much better, because they rewrote that. And when I worked on the library, binding between effector and the view, so it's much easier. But why I showed this example with the data computed and method, because I also worked on the second version with the binding. So it was so terrible experience.
Yeah, I agree with you. Thank you.
Okay, nice. More questions? You can raise your hand. Questions about TypeScript, Effector.js? Do we have hands?
Ask me about Effector.js.
What is Effector.js?
It's a new generation state manager, one more state manager, where you can make your business logic with easy. No, of course not. It's better. It's a story about atomic stores. You don't need the one huge store anymore.
Can you sell it to us? Like why should we use Effector.js?
First of all, it's free.
They all free, right?
Then it's easy to test.
It's
if you like a test, you should use.
And you have good TypeScript support. Is that right?
Of course.
How did you become a core contributor?
I started to make a wrapper for Vue, because on our job we used Vue and we didn't use Vuex. And we started to use Effector, but didn't have a wrapper, so we made our local wrapper, and then I just started to contribute. Yep.
Did they give like a badge of honor or something?
Of course,
okay.
Of course. You can see on my GitHub account.
Okay, okay, nice. Do we have more questions to Illia? Because my understanding is pizza has not arrived yet. It arrived? Ah, okay, so, but you can still ask questions though. So, no more questions? No more questions? From what I see, no more questions. Can you choose the best question then?
I like tests, so that Andrei won this.
Okay. Okay, Andrei, you won something, but I think you won last time as well. You already... Oh, okay, okay. So Andrei will get one of the TallinnJS t-shirts, right? Woo!